Hey calculus kids, this is Dr. Callahan with week 13 Friday. How are you guys doing with calculus AB? The following are your 3 questions for your warm-up, and so go ahead and pause the video and answer them, please. Okay, let's go ahead and take a look at question number 2. So this one is asking you to apply the mean values theorem. It's asking you to find the value C, where it is going to equal to it is going to be a point that's going to be in between intervals 1/2 and 2. That is also going to represent the slope. So remember, there are a few conditions that you have to meet. Number one is this continuous? It is continuous unless, of course, x is equal to 0, in which case it's going to be undefined. But that's not a problem because your interval is between 1/2 and 2, and 0 does not pose a problem in between that interval. So you are good to go. So check that baby off. F prime of x means that is it differentiable? So meaning that can I find the derivative f prime of x with this? So if you look at this, you will have to use the quotient rule. So I'm going to set it up as f equals x plus 1, f prime is 1, g is x, g prime is 1 as well, and then g squared is just x squared. So f prime of x is equal to, I'm going to have f prime times g, so that's just x, minus f times g prime, so minus x minus 1, all the way over x squared. And then if you look at this, the x cancels, negative 1 over x squared is your f prime of x. So number 2, check, it is differentiable. Third step is that you will need to find the average rate of change. Know that this part is the instantaneous rate of change, and then the fourth step is when to set the two equal to each other. So the average rate of change is going to be f of b minus f of a over b minus a. Well, given the fact that a is 1/2 and b is 2, let's go ahead and find them. F of b is going to be 0.5, actually I should keep it just in a fraction, I think I might just do that. So 1/2 plus 1 over 1 over 2. So let's go ahead and find the common denominator. So if I make that a 2, the top would be a 2, that's a 3 over 2. Divided by 1/2 is the same thing as saying times 2 over 1, 2 cancels, and that gives you a 3. Next, let's find f of a. F of a is going to equal to, I'm so sorry, I totally did this backwards. So that's actually f of b. So f of a is going to, no, I'm sorry, no, I did it right. F of a, there we go. F of b is going to be 2 plus 1 over 2, which is a 3 over 2, which is just 1.5. Okay, so now that I have these two components, let's go ahead and plug them back into the slope formula. So I have f of b, so 3 over 2 minus 3, all the way over 2 minus 1/2. So we have a bunch of fractions here, but that's okay. You guys are all smart kids. We can go ahead and figure this out. This is a 1, so I'm going to make that into a 2. Top then becomes a 6, and it would be great if my pen works, but it's not working right now. Equals is a negative 3 over 2. Over, that's a 1, so if I make that a 2, that becomes a 4. 4 minus 3, 1 is a 3 over 2. So if I go ahead and rewrite that, it's a negative 3 over 2 times a 2 over 3, which is going to give me just a negative 1. And that is your average rate of change. Fourth step, I'm going to go ahead and take my instantaneous rate of change, set it equal to the average rate of change. So my instantaneous rate of change is going to be negative 1 over x squared equals average rate of change is a negative 1 over 1. Cross multiply, negative 1 equals negative x squared. Cancel the negative, positive 1 equals positive x squared. Square root both sides, x is equal to plus and minus 1, and that is your C. However, the only one that I want to use is the one that's actually on the interval between 1/2 and 2. So can't use a -1. C is only going to equal to +1. And that is your answer, you guys. All right, so let's go ahead and take a look at our breakdown for today. This is your breakdown. Today we're going to go over extremas, which is concavity, maximum, critical point, point of inflection, concavity, concave up, concave down. We're going to go over 3 examples. And then I'm going to give you guys 3 rounds of practice problems. And so you're going to practice with that. And then I have a Quizlet at the very end for 39 questions. And so we will just do that. So first things first, I'm just going to jump right into the Quizlet before I forget. So you guys are going to type in this link in purple, capital G, capital K. If that link for some reason doesn't work, make sure you type in this one right here. It's a little bit longer, but it'll work. And then once you go ahead and type that in, you should have this part right here. And it's 29 questions and it's multiple choice. And it's just to kind of review some of the things we've done. Like for example, V of t changes sign. So what does that mean? What happens to the particle? If you pick one of the question, you get it wrong, you can go back and then pick another one. Okay, really need to study this. And then just keep going until you get to the right answer. And I'm really bad at this one because I picked all of them and it's apparently it says it's not. Oh, you know what? It changes. Just kidding. It actually did change. I thought I didn't. But anyways, make sure you guys go over the 29 questions and get familiarized with the concept of particle motion, with concavity, with critical points, point of inflection, maximum, and etc. All right. Now I want you guys to go ahead and take a look at your notes for today. This is your first page right here. And this is also our guided notes for today. 3 examples. And then afterwards, I want you guys to take a look over here. This is going to be your practice one in class and also some practice from the textbook. Then if you still need some additional practices, I have a video right here that actually goes over some of the questions from your textbook itself. Excuse me. That you can just simply click on the video right here or type it in and then watch the video with your guided notes. And these 3 pages are in your week 13 Friday note packet. All right, so with that said, let's go ahead and take a look at this and get going with it. So find that in week 13 Friday. All right, let's go ahead and fill out some of this stuff. All right, looking at this right here, what does the derivative represent? Well, the derivative basically is representing the slope of a tangent line to the functions f of x. So for example, if this is your function, your derivative is going to be this critical point right here, and it's going to represent the function of this tangent line. In this case, since it's a maximum, it is a slope of 0. When a function is increasing, what is the comment about the derivative at that point? It just means f prime of x is greater than 0, because if you have a positive slope, then you know that the slope is going uphill. Similarly, if it's decreasing, your slope is a negative, less than 0, so it's going downhill. Oftentimes, when you have your critical point, if you have a positive slope followed by a negative slope, you know it's a max. If it's a negative slope followed by a positive slope, you know it's a min. When f prime of x is greater than 0, then you know f of x is increasing. If f prime of x is less than 0, it is decreasing. And you know that when f prime of x is equal to 0, it is horizontal. Okay, that is a critical point where it's going to determine either a max or min by testing the left and right side of that critical point with a sign line. Okay, so here are the steps to the first derivative test. Now, we've already done this before, but it's always good to kind of have everything as a review, typed up, nicely organized. So I want you guys to go ahead and read this part before we go to example 1. Okay, sorry about that. I just had to go ahead and minimize this so that way I can see this. So that way when we do this, you can see the steps right here. Okay. All right, so let's take a look at example 1. All right, so with example 1, first step, it says determine the interval at which if f of x of is that really ugly thing right there is increasing or decreasing. Locate the relative extrema. So first step is find the f prime of x and set it equal to 0. This is going to be fairly easy. It's just going to be a power rule. So 1/3 times 3 is just 1x squared plus 5 over 2 times 2 is just going to be a 5x minus 6 equal to 0. Okay. And then it says, find the critical point for both the numerator and denominator. Don't need to worry about the denominator because I don't have one. And remember, critical point also exists where functions is not differentiable. So yeah, let's factor this out. Ask yourself, x times what is going to give you a -6, but when you add it together, it gives you a positive 5. I would say that it is going to be a -1 and a positive 6 because when you add the -1 and 6, it gives you a 5. And then your critical point is going to be a positive 1 and -6. So step 1, done. Number 2, put all of the critical points on a sign line. So here's my sign line, here's -6, and here is 1. I know that at these 2 points right here, the slope is 0, and I need to go ahead and test the left, middle, and right side of -6 and 1 to determine if it's a positive or negative slope. Okay, next part. Test the interval. Plug in the values into f prime of x to determine the slope. So let's go ahead and notice I'm doing the first derivative. So I'm going to pick a point that's in between those intervals. And I think the best point to pick at the left side of -6 is a -7. In between -6 and 1 is a 0. After 1 is probably just a 2. All right. And then when you go ahead and plug this into the equation here, and this is the equation that you're going to be plugging into to determine the f prime of x, to determine whether it's a positive or negative slope. I always said that you should use your calculator, do the graph, do y equals x squared plus 5x minus 6, hit graph, second, calc, x value, and then make sure you type in -7, 0, 2, and then make sure you push enter to determine what your slope is going to be. So you should find that -7 is going to give you a positive slope. It's going to give you a negative slope at 0 and a positive slope at 2. So what does that mean? If you're not sure, you can always draw this. So positive slope going here, negative slope going here, positive slope going there. And so if you take a look at this right here, that means that at this point, it is a maximum. And that maximum is at -6. Don't know what the y value is, so we have to put f of -6. But when you go ahead and do that, be careful because that has to be going back to this equation right here, okay, to determine the y value. Do the same thing over here. This is a min because it's a positive, or I'm sorry, a negative going to a positive. So your minimum is at 1, comma, and then f of 1. And again, you want to plug that into the original f of x to determine that. And you'll find out that your max is going to be at, and actually I don't, oh, here it is. Okay, sorry. -6, comma, 51 is going to be your max. And your minimum is going to be at 1, comma, -6 point, and it's going to be in a decimal, 167. And that is going to be your min. So there are a few things that you can go ahead and type this up. And I'm going to go ahead and just type it up so that way you can see it a little bit better. So a lot of times in the free response questions, they require you to write like a little sentence explaining what you found. So I'm just gonna go ahead and do it this way. Let's do insert. Oh no, that's not what I want. Insert text box. Okay, fine, don't do that then. So we're just gonna go ahead and insert the text box. And my sentence will look something like this. I will just say that f of x is increasing on negative infinity, comma, negative 6, union 1 and 8, or positive infinity, because f prime of x is greater than 0, okay? And then you can say f of x is decreasing on negative 6 to 1, because f prime of x is less than 0. And you can say that your related maximum is at negative 6, comma 51, because f prime of x changes from a positive to negative. And you could say your related minimum is at 1, comma negative 6.167, because f prime of x changes from negative to positive. If you have these 4 things written down, it's pretty much showing them that you really do know what you're talking about. And so that should be more than sufficient. All right, so let's go ahead and take a look at example 2. Okay. All right, so let's go ahead and move on forward with this then. Okay, so example 2 looks like this. Okay, so it says determine the interval of the function, whether it is increasing or decreasing, locate the relative extrema. So then looking at this right here, first thing I'm gonna do is I'm gonna find f prime of x. In order for me to do that, you would have to use the quotient rule. So let's set it up here. F is 5x plus 2, f prime is 5, g is x minus 3, g prime is just 1, and then g squared is x minus 3 squared. And I want to keep it like this, although you could factor it out, but I'm not sure if we're going to need to yet. So let's go ahead and plug this in. F prime of x is going to be f prime of x times g So I'm going to have a 5x minus 15. I'm just going to plug it in there and distribute it. Minus f times g, so that's a minus 5x and a minus 2. I want to go ahead and simplify this, so the fx cancels, and that gives me a negative 17 over, don't forget your g squared, x minus 3 squared. Okay? And now this is the interesting one where you have a numerator and denominator, and then remember it says find the critical point both numerator and denominator, and you just simply set the numerator and denominator to 0. Well, the numerator is not going to give you anything, but the denominator certainly will. And so you're going to put x minus 3 squared equal to 0. Well, to get rid of the square, I will square root both sides. Square root of 0 is still 0, so x minus 3 equals 0. And then add the 3 on both sides. X equals 3. That is your one critical point. So then, let's do a sign line. So 3 is right there. I don't know if it's a max or min, but I'm going to go ahead and test it out. So let's go ahead and plug a number in. Let's go ahead and do 2 on the left side. And let's do a 4 on the right side. So then what you're going to do is you're going to use the first derivative, which is this formula right here. And you're going to plug in a 2 here for x and a 4 right there for x to figure out if it's a positive or a negative. Now, given the fact that this is actually pretty simple for the most part, you don't have to do the graphing one, but if you want to, it could help as well, where you can do the second calc. Okay. Oh, for crying out loud, stop it. Okay. Oh my goodness. Okay, there we go. Hopefully it'll just stay there then. All right, so then once you go ahead and plug the numbers in, okay, you're going to find out that this is going to be a negative, and the 4 is also going to be a negative. So if I draw this, you're like, wait a second, there is nothing there. And that is correct. So what does that mean exactly? That means the way that you're going to write this is as follows. So this is what you're going to write up. Your write-up is f of x is decreasing on negative infinity to 3 union 3 to positive infinity, because f prime of x is less than 0. So what does that mean? That means no relative extrema for f of x exists. And that's all that you have to write. In some cases, you might not have one, and in which case it's completely fine. Okay. Let's go and take a look at example 3. Okay, so for example 3, it says make a first derivative sign line for the following graph of f prime of x. So this is the f prime of x graph, okay? And if you look at this, remember, I know it's been a while since we transfer like f of x to f prime of x. Just remember that with f prime of x, this graph is already showing you guys slope. And anything that is going to be above 0 here is going to be a positive slope, and anything that's below 0 is a negative slope. Okay, so number 1, I'm going to make a sign line, And if I take a look over here at my critical point, I have a -3 and a 2. And then from there, I can see that on the left side of -3, it is below the 0. So that is a negative. After the -3, it is, I'm sorry, I totally, yeah, it is correct. After the -3, it is still below 0. So it's still a negative slope. After the +2, it is above the 0. So it is a positive. So then what does that mean exactly? That means I have a maximum here at point 2 comma f of 2, okay? And then if I were to go ahead and sketch this graph, I am going to sketch it like this, where at 3, so this is my f of x graph. I'm going to have to go backwards. Here is 3, and then here is 2, or -3. And my graph is going to look something like between 3, it is still a continuous of a negative slope. So it's going to look something like this. And it's going to keep going negative, okay? But then at 2, it is to have a minimum right here. So here is 2. And that minimum is going to go from a negative slope to a positive slope. So it just looks something like this. And that is your graph. All right, you guys, so we have practiced with this. Now, if you are interested in practicing this a little bit further, you can go ahead and turn over to this page right here, which is the second page, and you can go ahead and find the maximum as well for the extrema, and you have several things that you can go ahead and practice with. All right, so let me just show you the answer. I'm going to pause this so that we don't see the answers, okay? So you can practice by yourself, but once you're ready, go ahead and take a look for 1 and 2. Okay, then let's continue on with questions number 3 and 4. All right, and then take a look at number 5 and 6. And that is basically it. So if you need some additional practice, like I said before, the very last page of what you have is this right here. You do have some additional practices that you can do with relative extremas. If you need some assistance, you do have a link that is available right here as well. All right, well, this is it, you guys. I hope you have a wonderful weekend. As always, stay safe and healthy and have a good night.